Thanks for coming, everyone. So we did this talk yesterday, and the order of operations yesterday was we did the fireside chat first, and then I did my talk afterwards. We found actually, I think, that the audience would maybe like to see what Trino and Starburst looks like first, and the fireside chat gets you a bit of that historical storytelling. Where does the project originate from? Where is it going? Those that are open source users in the startup community get some insight into how Trino was built and where it's going to be going in the future. Those that are from the enterprise community, how Starburst is helping those enterprises adopt a data platform at scale. So let's see if this order of operations is better than last night's, and we'll kick it off. So my name is Michael Markieta. I'm the lead solution architect for Starburst. I'm based out of Singapore, and I travel every other week to another country in this region. So I'm here in Sydney and Melbourne every few months or so.
What a great life.
So Trino, the open source project, has been around for quite some time now, originating at Facebook. We've got one of the co-creators here with us today and one of the founders. So Martin, thank you for joining us here in Sydney, coming all the way from California. The project itself is very successful and widely adopted. So the digital natives around the world, such as Netflix, use Trino to query data in a data lake that's massive in scale, unlike what most enterprises have today. So 25 petabytes under the hood that Netflix is happy to share with us and tell us that this is how much data they're querying. They're probably operating at a much larger scale today. LinkedIn talks about an exabyte of data with many hundreds of thousands of queries executed on a daily basis. And you can see the other facts on this slide itself. Starburst, as a company, originated from this group of creators to build enterprise services around a query engine that an enterprise can adopt, because an enterprise needs things like security and governance. They need an ingestion framework. They need both batch and interactive analytics at scale on top of that data lake. Martin will talk about how Trino was used to solve a problem that they had at Facebook. The short answer is that Hive and the Hadoop ecosystem wasn't working for them at that scale that they operated at more than 10 years ago. So Trino solved the problem where Hive was failing, and Starburst continues to solve that problem today at petabyte scale with the largest banks around the world, the largest telcos around the world, all flavors of companies. I like this hamburger diagram where we have clients at the very, very top. So you can probably familiarize yourself with the BI tools that you typically use in your day-to-day, the Lookers, the Power BIs, various different dashboarding tools, and the clients that you might use. So if you're a data engineer, you're using Python, PySpark, and other tools. Those are the familiar languages, technologies, pieces of software that connect to Starburst. Starburst in the middle here is the query engine. It's that horizontally scalable architecture that allows you to submit a SQL query, submit that logic, and allow us to query data that is at the bottom of this architectural diagram. So what we can access, and what's really nice with Starburst, is we're not only targeting what Facebook originally had problems with, which was their Hadoop data lake. We can also target a variety of other different types of data sources. So Starburst is used by many to query their data lake, as well as Postgres, MySQL, Oracle, and traditional data warehouses. Various different NoSQL or semi-structured data stores like MongoDB, JSON records that are stored in a lake, acting as a place or repository to dump data. We can also query Kafka streams, which is a nice side effect. So if you want near real-time analytics, that you want to join data from that stream from Kafka and attach that to data that is currently existing in the lake. Those are all capabilities that Starburst and Trino bundles under the hood. Starburst really contributed quite a lot of these features that enterprises were looking for around things like data masking. So, users that want to access data in the lake, maybe not all of them should be able to see all of that data in plain or clear text. So being able to query data in the lake that contains PII data but automatically mask it on the fly is a nice to have. Or maybe packaging up some data as a data product. So associating metadata with a SQL query, documenting that and sharing that with your organization, and providing access and governance tools to how someone might use that data product, something we can help you with. So a lot of these features are things that we built to build a full platform that enterprises could adopt. Quite a lot of features. I won't ramble along all of them. So Trino, if you're using it today, you're probably familiar with this deployment model and interaction. It's a CLI-based interaction. It deploys on virtual machines or Kubernetes. It's very much a low level. Someone who's a software engineer might be happy deploying Trino, but if you're a business that wants to leverage Trino, you might want a UI, you might want various different integrations with single sign-on providers, things like that. So what do we help? We help you with two different types of deployment models. There's Starburst Enterprise, which is a type of solution where you can deploy it on infrastructure anywhere where you operate that infrastructure. So that might be Starburst Enterprise deployed in your data center in a fully dark site, not connected to the internet, which allows you to query your data lake on premise that could be petabytes in scale. We also have Starburst Enterprise deployed in cloud on the various different cloud vendors' Kubernetes offerings. Or you can deploy it on virtual machines or bare metal. Aside from Starburst Enterprise, if you don't need that full control deployed anywhere, we also have a SaaS offering. The really nice thing about Starburst Galaxy is that it has a click-to-deploy model. So any software engineer that has deployed Trino in the past knows the pains around orchestrating and deploying Trino. With Starburst Galaxy, you click a button, get a cluster, it spins up very, very quickly, and then you can just start using it. And also, the nice thing is that it can automatically scale down to 0 and hibernate for you. So when you don't need it, you're not spending any money on that cluster being online and alive, consuming resources in your cloud. Nice to have. I'll talk about the use cases for Starburst, and then I'll give a demo of Starburst so you get an idea of Starburst features and functionalities and how Trino works. And I'll call out what is Trino specific and what is the unique offering of Starburst that'll help you, in your mind, separate those things. So when Starburst was built, it was built on top of a connector ecosystem. That connector ecosystem meant that I can connect my Trino engine to a data source. And there could be many different data sources that I can connect to. A byproduct of that meant that I could also join data from many different sources in one SQL query. So if I had two data sources connected in Trino, I could then do a select from one table and one location of data. That could be my data lake. And that same SQL statement can join data from, let's say, a PostgreSQL data source. Starburst would effectively pull that data in from those two sources, perform the join in its cluster, or Trino would do that, and then would expose the results to the end user. Where we were born is data lakehouse analytics, so a Starburst cluster. It's going to perform really well when we can attach ourselves to data sources that have high throughput, high bandwidth. So object storage in cloud, so S3 APIs, Google Cloud Storage APIs, ADLS in Azure. These are data sources that allow us to have many parallel connections from our cluster to that storage to be able to pull files out very quickly, to then perform the analytics in memory inside the cluster itself. So without having to read and write back to disk, we don't have to spool any of that data. We can, with very large clusters, do petabyte scale analytics with quite low latencies. In some organizations, you might run Starburst for interactive queries. So I'm just going to be an analyst. I want to query data that's in my lake or in my Postgres database or whatever number of data sources that I have. But you might be an organization that uses Starburst for both interactive analytics and batch processing. So when do I use batch processing? Maybe I have some ETL pipelines where I want to go from bronze to silver to gold layers, building a Kimball model, or maybe I'm doing regulatory reporting. And that regulatory reporting needs to be performed on let's say it's an hourly basis, daily basis, end of month basis. That regulatory reporting is very strictly governed in terms of SLAs. It needs to complete by a certain time to be able to hand off to the regulators. You might deploy multiple clusters for that. So one cluster for interactive queries, a cluster for that batch processing or ETL pipelines. So it's a very common use case is to have more than one cluster deployed and then load balance your queries to the correct cluster smartly behind the hood. I mentioned this already, so data products, what are they? In a data mesh strategy, what you try to do is give access to your users to some sort of data. Rather than all of that raw data that Starburst and Trino can query, why not document very thoroughly the data that would be most the best use for your user? So maybe it's a customer 360 type data product. That data product, it describes all of the metadata that would be required for someone to be able to discover the customer 360 data product, understand how to use it, some example queries, who created it, who do I contact when it doesn't work for me and I need some adjustments. That's very, very useful. And then you can publish it in Starburst. So Starburst provides the UI for you to be able to publish that and share that with your users. And lastly, one of the other use cases that we're seeing more frequently now is using Starburst as an embedded engine behind data apps. So data apps is just a catch-all term. You might call it a smartphone app, mobile app, could be a dashboard, a white label dashboard. It could be your own internal naming convention for something that exists to analyze data at any sort of scale. As an engine, what we do is give you access to all of that data that you previously had to store in a transactional database to power your data app. Transactional databases work really well for that, but they are expensive at very large scales. So our proposition here is that Starburst at very, very large scales is a really good price for performance. And those data apps might not need the transactional database latencies, which could be down in the millisecond range. If you don't need millisecond range, maybe you need a better price for performance lever, and Starburst can help there. Last slide, and you can ask questions. I'll go into the demo. So Trino's architecture is fundamentally based off of two components. One is the Trino coordinator, which is the brains behind the system itself. So users, which are on the right here, go through a load balancer. This architecturally could be the Kubernetes load balancer, your cloud load balancers, your on-premise F5 load balancers, whatever that is. Those requests end up at the coordinator. So the coordinator here accepts that user's requests. It could be a SQL statement that needs to be evaluated. A query plan is generated. That query plan is used to then obviously distribute the work amongst those Trino workers that are below it. The Trino workers, you can see they're in a dotted line, and auto-scaling group is annotated there. So you can have many Trino workers. The goal here is that you can scale out your infrastructure horizontally to get more performance and higher concurrency. So at very small scales with small amounts of data or small amounts of users, you might need a very small cluster, and that's fine. But if you have hundreds of users that are all asking of questions of data all at the same time, you're going to want more capacity to be able to handle all those questions that are happening at the very same time. How does that relate to something that maybe you're more familiar with? If you've got a data warehouse, you need to vertically scale usually that data warehouse, or have many appliances that are load balanced to be able to get that scale at the very, very high concurrencies. So in this case, if you just need more power, you just add more workers in your node group. In the Starburst architecture, that Trino coordinator can contact identity management solutions, so single sign-on with your various solutions like Okta or Azure Active Directory and so on. External data authorization. Maybe you have a tool already that does data authorization for you on another platform like Apache Ranger. We can make use of those as well. And metadata management. So, in the open source community, you may be using things like Open Lineage, Open Metadata, Open Telemetry. We expose all of those endpoints as well, so you can make use of those in your open source tools, or there's many different enterprise tools that connect to us and be able to leverage the same content. I'll pause there. I went through this section really, really quickly because I wanted to jump into the demo, but if there's any questions now, I'll pause and take a breath. Yes?
Hi. I'm a data engineer,
yeah.
So ETL happens a lot in my day-to-day.
Yeah.
I hadn't heard of Starburst before. And talking to a lot of people tonight, people come from a lot of different backgrounds and tech stack. So I wanted to ask, in terms of use cases and features, how would Starburst compare to something like Microsoft Fabric or AWS Retrieval?
Yeah, there's lots of tools in this space. So Trino, I'll talk about the open source first. So Trino is fundamentally a query engine, which gives you access to a great amount of horizontal capacity to be able to perform those transformations on behalf of a tool that has orchestrated the ETL for you. So a common pattern that we see is Apache Airflow as an orchestration tool, maybe dbt to design the models for transformations, and then Airflow tells us to schedule the SQL statement that needs to run, which is a pipeline, obviously, that goes from versions of tables through that entire process. We're not an end-to-end platform for ETL design. Obviously, we depend on Apache Airflow and dbt to do some of that, but we're a very good engine in terms of the price price for performance conversation in that situation. You have other tools internally inside of Starburst that help users have really strict governance and access controls. So as a platform administrator who wants to allow a group of analysts and users access to data, I mean, not data engineering specific, but there's a wider group of people that you need to support with your data, you might have full blanket access to be able to build pipelines and create data sets, but you want the end users to consume, let's say, the gold layer of data that's at the end of your pipeline. So there's a lot of that that's built into the system. And that was the original design with Starburst, was to make sure that we're ticking the boxes on the enterprise governance side of things for those end users at the end of the day. From an engine performance point of view, a lot of the engines are comparative. We are constantly benchmarking. They're benchmarking. At one point in time, one engine is going to be faster than the other. As Martin says, it's not rocket science. There's going to be always a leader at some point in time, and then they swap places. He can expand on that. He's one of the creators. Yeah. Good question, though.
Thank you.
Yes.
We are using it actually. If I had data from two different databases, so let's say MongoDB and NoSQL database, and I queried both of them, and I asked the engine to get me, top users of both of them or whatever. How fast is that internal query of those different data sets? Is it comparable to databases individually, or slower, or how would you?
Yeah, good question. As long as you add more layers to the architecture and you need to make network jumps, it's going to be slower. So we're going to push down as much of the query to the underlying database engine as possible, retrieve data so that you're paying the cost of doing that. So it's never going to be one-to-one with that, so querying that database engine directly will be better. But if you have a solution where you need to be able to access multiple data sources, the time it would take you to synchronize data or move data from one source to another might be slower than the actual fact of being able to federate. Or the business value that's generated by being able to federate is far greater than the costs associated with creating that synchronization between the two data sources. Or co-location of data, which is one of the strategies that a lot of organizations have tried to do for many years, which is bring all of my data from all of my sources into one location, and we've always failed doing that because it's very hard to do that. Data lakes, the original implementations of them were just put everything in the data lake and it becomes a data swamp, as people like to call it. So yes, it's going to be a bit slower, but the advantages of a data mesh strategy with federation can far outweigh the performance or latency costs that you get. Maybe I'll go through some demos, and you'll see and be able to ask questions as I go through. If there's any other questions yeah, go ahead.
I was curious, most companies aren't Facebook or LinkedIn, so maybe that's the one in the world.
Yeah.
How much data do you have to have? I know that's probably an unfair question to some degree, but
yeah.
For something like Trino.
If you're using a lake already to store your data, open source Trino or Trino under the hoods of a query engine is going to be able to access that data. And you may already be using Trino if you weren't aware of it, if you're using something like Athena. If you're on-premise and you've got tens of terabytes of data, maybe it's a good use case as well. Obviously, at tens of terabytes of data, a transactional database would also be able to solve your problem. So you're weighing the cost of running a transactional database for that quantity of data, because the amount of storage in that case is not so high. We really shine at high concurrency, so it's not only volume of data. So if you've got thousands of users that need access to terabytes of data, and they're at high concurrency, so many of them are querying at the exact same time, being able to have a scale-out architecture allows you to solve for that problem, which you can't really easily do with a transactional system. Yeah. I'll run some queries here just to show you, because I've been talking about joining data from two sources and I haven't actually shown that yet. So in this query, the only thing that's different that I want to call out specifically is that there's a Hive dot at the very, very start of the reference to the table that I'm querying. That Hive represents one of the catalogs that is loaded into my list of catalogs in this case. So if I scroll down, I have Glue and I have Hive. Those are both sources of data that are in object storage. So that's S3 on AWS in this particular demo environment. All of my schemas here refer to schemas and tables that I have stored in the cloud, and they could be a variety of different data source types. In the majority of cases, it's either Hive or Iceberg for our demo data set. sets, but we support all of the major, modern table formats. So you've got Hive, Iceberg, Delta, Hudi that you can query. So whatever you're using in your organization, we probably support it. And then obviously the joins between two tables from two different sources look like this. So you've got Hive and Snowflake parallel. We go out, we retrieve data from those two sources, we pull that back into the cluster, we perform the join in memory. In cases where we have a joining key or a predicate filter, we can do things like push down that to a data source. That data source will perform some of that filtering for us, so we don't need to retrieve the entire table from Snowflake first to be able to perform the join. We only retrieve the data that we need for the join. And in this case, it's a very simplified example. It's not just two, you can join from multiple sources. So I've got examples with organizations that have 30 Postgres databases and they're joining across all of them. They're doing that in ELT land, where they have, their 30 Postgres databases and they're trying to build one data lake that's very performant, that gives you a very, very wide table with a wide view of all of the data that exists in all of those databases. So rather than a CDC pipeline, it's actually Starburst that queries those Postgres databases on an hourly basis to retrieve and merge data into a data lake for analytical purposes. Pause there. Any more questions? Yeah.
Sorry, me again.
Yeah, go ahead.
You said you have Starburst and data mask, so you got pieces of data if not it gets hashed or not.
Yeah.
What is the exact pipeline? The first check permissions of the user, or does it first grab the data?
Order of operations is something I'm not confident in saying, because if I get it wrong, then maybe it's a bit embarrassing. The fact at the end is that the user never has access to any of that plain text data. So whichever order it is it's done in memory. So data is accessed obviously by workers, pulled into memory. The operations for the SQL statements are performed, and then when it's presented to the user has only access to mass data. I don't exactly know, but the permissions are checked during SQL evaluation time for things that they have access to. So if they don't have access to a column, the SQL statement will never actually extract any data. So that SQL query will fail fast, fail early. Yeah.
So what will happen? Will it just be a bunch of asterisks, or what will it, like, how does it mask it?
Yeah, you can choose. So you can provide either custom functions or use built-in ones. So you can use masking where you completely mask it out into null values, into asterisks. You can do one-way hashing so that you can join data. So if you've got an address, two addresses and two tables can be then joined because it's a one-way hash that is stable using SHA-256, I think, as the built-in. You can have other custom ones as implementations. Just wanted to talk about performance because it was brought up. So in this case, I'm querying a fairly large data set. This is ride-sharing data, so the equivalent to like an Uber data set, or maybe DoorDash. In this case, we're querying data with a few filters. At this case, we're querying at about 116 million rows per second, and it's fluctuating up and down. We're only retrieving about 20 rows, but in this case, because we're retrieving from object storage, we have to pull all of this data into the cluster to filter it because we don't know where the records are. We're not indexing or caching any of this data. On object storage is just a dumping ground for those tables. So there's no way to know exactly where that needle in a haystack query, where those records are. So 20 records in what is billions of rows. If I take a look at the details, I think we can, 4.5 billion rows were read over that time. So what happened here? We talked about the horizontal scalable nature of the cluster. All of those worker nodes that are in the auto-scaling group, they make connections, multiple connections to object storage, pull Parquet files from object storage, and then process those filters in memory in the cluster. Very simplified version of what Martin's probably cringing in my description. But anyway, that's what's happening under the hood, which is really nice because one of the features that we have, and also simplify it as well, is something called warp speed. So warp speed helps you accelerate those queries. So every time I run this query, I read 4.5 billion rows, I click run, and I have to retrieve all those rows every single time. It's very expensive. So you pay for egress costs every time you do that. So if I look at warp speed is smart caching and indexing. So what we do is we cache the data, those Parquet files from object storage on the cluster. So the cluster that we have has NVMe drives attached to the nodes, and we can store those Parquet files directly on the nodes themselves. So rather than having to go back to object storage, we can run this query, and we should be able to leverage the cache. I'm going to turn this off. It's using result caching. I don't want to use result caching. Let me run it again. Okay, 12.8 rows per second, so very slow. Because it's only reading those 20 rows directly from cache, it's not using the result set cache. Result set cache is basically a similarity check. If this string for the SQL query is exactly the same as what was run previously, it will use that cached data. But in this case, we actually did a SQL query. We performed some sort of analytics, but we used lake acceleration. So in this case, 100% of this query was accelerated. If we take a look at the advanced, the particular amount of rows that were read and bytes that were read is very small. So we never went back to object storage to retrieve data. We just used the latest version of that data, which was cached on the nodes themselves. So very, very fast. So saved a lot of CPU and compute and storage. Okay, last bit of demo is the LLM stuff. So to power an LLM or AI conversation, we want to maybe democratize access to exploring data by asking questions in plain English, or whatever language you want to use, and then be able to have that conversation with the data set behind the scenes. So in this case, we've set up a bit of a demo where we are able to ask questions of a data set. Hopefully these 404 errors aren't a problem. Demo gods, pray for me. Okay, we're low. This data set looks a bit small. Let me go back and try this again. And go back to the yesterday's demo. Maybe this will load. Yeah, okay. Okay, we'll run the queries again separately. So I've got a notes tab. So this data set is a data set of a fictional bank. There's 47,000 records in this bank. Let's pretend we're an analyst. We don't know much about data. We don't know how to write SQL. We just want to ask questions of a data set from a data lake, which our data engineers build pipelines for, build data products for us. So they're very well documented. There's a lot of metadata associated with them. But still, I don't know how to use SQL, so I'm going to talk to it. I'm going to talk to my data as if I was using just plain English. So generate talking points for offering a mortgage to diamond status customers. It's read this query. What we've also done in the back end is we fed the data product. The data product's that box, right? So it's the metadata and the SQL queries. We fed that into the model and said, this is the data you should be aware of, that I want you to be able to base your responses on. Behind the hood is generating SQL queries. It's asking information about that data to be able to generate a response. LLMs are not very fast today. They'll get faster as time moves on. We've been seeing the improvements with ChatGPT and other solutions out there. So hopefully this does work. I think we're getting, okay. So here's some talking points. So as an analyst who doesn't know how to use SQL, I've started to understand a little bit about the data. And in this case, this data set talks, a little bit about, a customer segmentation, who has maybe a high risk appetite, with references to maybe rows or records in a data set. So I can start to maybe refer to the actual data that's been presented to me or that I've been given access through. I have a few other questions, but I want you to think about questions that you want to ask this LLM, and I'll type in your free text question after this one runs. So if anyone has any ideas for questions to ask of this, theoretical demo data set about, customers that exist in the banking ecosystem, it could be anything. It could be a funny question as well. We can write it. Yeah.
How many unique customers do you have?
How many?
Unique customers.
Yeah, can do that. So this is just going to output this response, and we'll put in that one.
Should be relatively straightforward because you're probably querying from one source.
Yeah. So in this case, what we're using is a data product to power this LLM or this chat experience. So when I run this query or ask this question, it's basing it off of a package of data. So that package of data, I can go into actually the UI. So if I click into the UI here, I have an experience where I see a catalog of data products that have been published. Unfortunately, there's a lot of solution architects like myself just build data products, use test in the description, test in the name, so there's a lot of junk in here. But if I click on this very first one, which looks really nice, hopefully it's published well. Yeah. So we've got some metadata information, descriptions. All of this content can be fed into the LLM via a RAG model workflow. So it knows about the customer 360 experience, data sets that are associated with it. If there was reference or relevant links, we can follow those relevant links and collect even more information to feed into the LLM. And then at the very, very bottom of the data product are the actual tables, materialized views or views that a data product contains. So this is the core data that's being used for this chatbot experience. Okay, so based on it's calling it CSV data, the LLM's assuming that it's CSV data, because that's how it's being fed into the model, as CSV records, or comma delimited records. This one it cannot accurately determine. That's because, and it tells you why, the data contains multiple entries for the same individuals. So it's maybe actually identifying something that is a problem with this data set, a data quality issue that you can feed back to your data engineers who built the pipeline to build this data product, right? If there is repeated customers in a gold layer data product of customer 360, is there an opportunity to include a unique identifier column like customer ID, which is not present in this data set for this purpose. So, I mean, it's a take. It could be hallucinating. It could be true. An analyst still needs to use its brain or their brain to interpret the results of this output.
Does the database actually don't have any ID column in it?
It does. In this particular case, this particular data set was probably not published with one customer ID. Yeah. Yeah. Yeah.
Can you see the generated SQL?
Yeah. I'm going to have to go sort of behind the scenes, so maybe just find me afterwards and we'll take a look together. I'm going to have to go through some of the code to exactly see. This is not my demo, it's a shared demo environment. Yeah.
Just one, I don't know if this is a suggestion, but with the DeepSeek model, there's like a chain of, you can see like the chain of thought behind the scenes.
Oh, yeah, so this is not Starburst. This is Starburst solution architects who have built an experience that could be similar to what you might deploy in your organization. Yeah. So this is the art of the possible. This is not the Starburst UI. This is just us building a solution that you could build. And it's working today. So I can give you an example. We have a customer, NTT Communications, a telco in Japan. They are providing a chatbot experience inside of Slack and Microsoft Teams for users to be able to query about customer experience, to understand where there's network topology issues or performance issues or degradation on their network. So are they experiencing a lot of network outages or performance degradation in Osaka? That kind of stuff can be discovered via chat experience. Yeah. Yeah.
I mean, like, this kind of question maybe you answered already just now, but if I understand correctly, you interfacing with an external LLM or a provider, a service provider, and is there any chance that you could build this internally so that whatever you access, maybe it's an internal LLM, take care of the privacy issues, data,
Yeah, that's a great question. So Martin's going to talk about the future direction of the company. I think that's one of the questions we want to answer during the fireside chat. So, what are our thoughts around AI as an organization? How can Trino help in that space? I think we can talk a little bit about that. Yeah. Yeah, lots of questions. Go ahead.
Sure.
And stop me if we're running over time.
So this LLM is actually operating on queries. You're like loading in queries.
We're not loading in queries.
So you're not loading. So it's basically taking source side and making inferences of the data.
Yeah, so what's being fed into the LLM is all of this content that you're seeing on this screen. So it's all of the metadata that's associated with some tables, the table structures themselves. So if I open up these guys, we'll see that we have column names, data types, column descriptions. You could feed in as much metadata as you want and pack that into the model so the model has an understanding, and then it will generate its own queries, which could be hallucinations, or they could be very good. So there's that level of how much do you trust the output of that response. Yeah. Go ahead.
If my mental model is correct here, Trino is sitting on top of one or many data sets.
Yeah.
Can you kind of weight the authoritative nature of those data sources? So maybe some of those data sources are less worthy, possibly more latent. Can you sort of nudge your LLM to kind of like favor result sets in one data source over another data source?
That's a pretty good idea. So data products themselves can be built and organized in whatever manner you have. So we have I mean, it's a very crude starring system that users can contribute to that can be part of the metadata that you use to say, I trust this one more because there's 100 individuals in my organization that trust this and like using this data product. You could also just have metadata that says the category or classification of this data product is gold. And I trust this. It has 100% authority. It's truthful. And then I have silver, which is, there's a chance that there could be something wrong in this data product. You can't trust it as much. Feeding that information into the LLM so it can make a decision is something that could be interesting to test. Whether or not the LLM takes that context and uses it correctly is another question, since we don't control that. Yeah. Yes?
What's the underlying model?
This one I don't know. Do you know, Martin? Yeah, okay, I can do some digging. By the way, my name card is on the table over there, so please grab it. If you have any questions that I haven't been able to answer, you can also contact me anytime. Yeah. Are we good on time? Okay.
We're on time, yeah.
Awesome.
Round of applause.